Welcome to the Insightful Professor. Today's topic is multi-table operations, the outer join. We've already examined the inner join. Now it's time to address how the outer join behaves, and that's the focus of this video. So a quick review of the inner join. It's been a while perhaps since you've taken a look at that, so let's see what this involves. Remember that the join is effectively a select statement that is accessing more than one table. Technically, a join is only going to involve two tables, but we think about the idea of having 3 tables, 4 tables, 5 tables. That's really a case of just having multiple instances of a join operation. Now, what is the inner join? Well, the inner join is the result of taking a row from one table and finding a matching row in the other table. By matching, I mean we specify a join condition or predicate that involves relating a column from one of the tables to a column in the other table. And if a row satisfies that condition, if a match is found, then that row appears within the result. But the way the result row is constructed, it's a concept of concatenation, appending the data of a row from one table to a matching row from the other table. Now, the original tables are left intact. They're not affected by the operation because the join is effectively a read operation. So we have not altered the content of either table, but we've produced a new table, the result table. Now, the syntax for performing the join is relatively simple, but it's really understanding the semantics or the nature of how to perform the join, what tables to bring together, and how to relate them that presents the challenge. That is expressing that join or matching condition. Now, the ANSI SQL standard has a variety of different types of joins. These were brought to your attention in the earlier video on inner join. What I want to remind you of is in that previous video, all of these things that I've noted here in green are topics that were covered in that previous video. We are skipping over the column name join because it's really not needed. I didn't address it in the previous video, and I'm not going to address it at all. But the focus of this video is the outer join. So this is what we're going to take a close look at in some detail here. Now, when we talked about the inner join, we talked about 2 ways of expressing that. Using comma-separated syntax, multiple tables listed in the from clause, and the alternative is a condition join. You use the join keyword, specifying the join as an operation, and you separate the 2 tables by that operation. Then what you do is you include an on clause to introduce the relationship or the join condition that is relevant for that particular operation. Well, that's the form of the outer join we're going to look at because that is standard. So the outer join, as I introduce it in this video, works with Oracle, DB2, SQL Server, and the list goes on and on and on. Any database that's considered compliant with the ANSI SQL standard would support this form of the outer join. Just for completeness, I mentioned that Oracle, SQL Server, some other systems have their own unique or proprietary syntax for doing the outer join, but it's not portable. So we're going to stick with simply the conditional join ANSI standard syntax. Now, we asked the question, what's an outer join? But we answer it by first reviewing a little bit of, say, the characteristics or features of the inner join, and then we adapt our solution to say, well, now that you see the inner join, this is what an outer join is. So an inner join produces a result table that contains the matching rows from the 2 tables participating in the join operation. The match, as we see in this following join, which is an inner join, is saying we're going to take a row from the staff table, a row from the department table, and do the concatenation, appending data from one row to the other to produce a new kind of elongated row that will be present in the result table, provided this join condition here is satisfied, that the value of the DEPT column in the current row from the staff table being considered is equal to the value of the DEPT column from the current row from the department table being considered. And if we do find this match, or two rows with the equal values in the respective DEPT columns, then we form a join or the concatenation of those two rows, and that new row is then thrown into the result table. But the point is we get only the matching rows. So if you have a row from staff that has a department ID for which there is no matching department ID in the department table, that row from the staff table will not be present in the result. And similarly, if we have a department row with a department ID that is not found in any of the staff rows, that row from the department table will not be present in the result. So those rows are considered to be non-matching rows. They are not part of the result of the inner join. But suppose we wish to include those non-matching rows from either or both of the tables. That is the function of the outer join. Now, the outer join is said to preserve the unmatched rows. And the unmatched rows could come from one table or both tables. So there are three forms of the outer join, what is referred to as a left outer join, a right outer join, and a full outer join. And we'll explain each of these with examples. Now, before explaining these, let's consider why you would want to do this. Just because you can use an outer join is not sufficient motivation to do it. You have to recognize what this gives you. So we say, let's consider why we want then to keep the non-matching rows as well as the matching rows, right? We're doing a multi-table operation. That's what the join is. So obviously it makes sense to produce a result that has data from the two tables. But why would we want to include data that comes from only one of the tables, even though we're producing this multi-table operation type of a result? Seems kind of odd. Well, the motivation is such that we might consider, for example, going back to staff and department, that we could have departments that have employees assigned. Hence, the inner join will show us those departments as well as the employees. But we could also have some departments which currently don't employ anyone. So there are no employees assigned to the department, yet we still want to see information about that department appearing in the result. So that's where we would use an outer join. Well, here's the result of the inner join. If you remember from my previous videos, we have 9 rows that exist in the staff table, and we have 4 rows in the department table. When we perform the outer join, we'll see that we can bring back as many of the rows as we want from either table. It doesn't have to satisfy the join condition. But when we do the inner join, we express the join condition here, and in this case, it's equality. This is what's called an equijoin. More precisely, it's an inner equijoin, which means that what we're going to have is only the rows from staff that find a match in the department table, and only the rows from department that find a match in the staff table. And what's the match? The respective DEPT columns have to be the same. So we're looking for values in the DEPT column of staff where we have the exact same value in some row in the DEPT column of the department table. Once we've done that, we have found rows that have satisfied the condition. So observe the values in these two columns, which I presented side by side to make it a little easier to recognize what the match is. So notice we see philosophy and theology as the only 2 departments. But again, if you're familiar with my department table, there are 4 different departments. Furthermore, we have 9 employees in the staff table, yet only 6 of them are reflected in the result here. So the explanation comes about by looking at the individual tables. When we talk about the tables, we're saying, let's take the DEPT column from staff, and that would be over on this side here, and the DEPT column from department, and that's over on the other side, and we're looking for an equal condition. So you can see what I've highlighted in blue here in the respective DEPT columns. Those are the things that match. What I've indicated in red show us some interesting stuff. Notice that in the staff table, there is an employee assigned to math, an employee assigned to engineering, and then Da Vinci has a null department. There is no match for something being equal to math engineering, and of course nothing would be considered equal to null. So in the other table, we also have values that don't match in the staff table. We have CIS and management. So what that means is the non-matching rows from staff would be the rows that identify the employees of Euclid, Archimedes, and Da Vinci. The non-matching rows from department would be the rows that identify CIS and management departments. So neither of these sets of rows, we don't see CIS and management, we don't see Euclid, Archimedes, and Da Vinci, we don't see any of these rows appearing in the result of the inner join. The outer join gives us the option of including the rows from department that don't match, or the rows from staff that don't match, or both sets of non-matching rows. So let's produce a result then that shows the departments that have employees, but also shows the departments that don't have employees. So clearly we want to form the inner join to be able to identify those departments that currently have employees. So that's easy. But now what we want to do is preserve those other rows. Keep those in the result as well for the departments that don't have employees. That's where the extended syntax comes in to show the outer join. So those rows that fail to satisfy the join condition, that is, there's no matching employee row found in the staff table for a particular department, that is a row we want to keep. So we'll designate the department table as what's called the left table. See, what we're doing here is something called the left outer join. And we'll explain the difference between left, right, and full as we go through this. So we designate the department table as the left outer table, And what will happen is, remember, the departments that match, that have employees, we're going to get information that describes the department, and we're going to get information that describes the employee. But for those rows from the department table that don't have any matching staff member, any matching employee, what's going to go into the e-name column, the e-title, the e-salary, or the staff DEPT column? We're not extracting any values from the staff table to populate those columns, but those columns have to be populated with something so that the row remains structurally the same, has the same number of columns as every other row that's produced by the inner join part of the operation. Remember, the inner join is going to show us the columns from staff and department. So every row that goes into the result table will have to have a column value for every column from staff, every column from department. But when we have rows that are found only in department and staff contributes nothing, because there's no matching row, we still have to put something in those columns. These rows are said to be null extended. The system will automatically insert null values into the columns that are designated as columns coming from the staff table when these concatenated rows are produced and placed into the result set. So here's how we would formulate the outer join. First, we say, let's select from department and staff, and here's the condition. Remember, this is the condition join, so we're using the on keyword to express the join condition. We've already seen join as an operator, and when we didn't give any label and just said this is a join, it was an inner join. So now what we're saying is we have an outer join. But remember, there are three flavors of outer join. So we're saying what we want here is a left outer join. Now this is where it gets very interesting. What happens is, when we talk about the joins, the join is a binary operation. It's just like looking at an arithmetic expression where I say take a number such as 7 and add to it a number of 3. So it's 7 plus 3. Or take 7 and multiply it by 3. 7 times 3. The arithmetic operator, whether it be addition, subtraction, multiplication, whatever, is said to be placed between the two operands. It takes kind of an infix format. It's an infix operator. So you're saying number, arithmetic operation, number. So the two operands are on either side of the arithmetic operator. Well, that's exactly how the join works. The join is also a binary operation. You're saying department, join, staff. So that makes it very easy to understand what the outer join is going to do. Because what happens is we specify that this is not just a join, not just any old outer join, but it is a left outer join. Notice that our operator sits between the two tables, and the name of one of the tables, in this case staff, is placed to the right of the operator. And the name of the other table, in this case department, is placed to the left of the operator. Again, that's characteristic of an infix operation. So what we're saying is identify the table that is to the left of the operator. That's department. It is that table whose extra or non-matching rows, if there are any, will be included in the result in addition to the result of the inner join. So this will give us the same result as the inner join plus the extra or non-matching rows from the left table, which in our example is going to be department. So this will show us all departments that have staff members, and in addition will show us those departments that don't find a match with any staff member, departments that don't employ staff members. That's where the extra or non-matching rows will come from. So we also have the concept of a right outer join. And when we perform a right outer join, again, it's an infix type of operation, and the tables are positioned one to the left, one to the right. And what we're simply saying here is include the extra or non-matching rows from the right table. So in this example, the right outer join will preserve the extra or non-matching rows from the staff table because staff is positioned to the right of the outer join operator. Now, question is, do we need to have both a left and a right outer join operator? I'll let you think about that for just a moment. Well, we really shouldn't have to have both of them because observe what's going on here. I'm taking department and doing an outer join with staff, and I'm saying, give me the extra non-matching rows from the staff table. Well, here I'm doing an outer join with department and staff, and I'm saying, give me the extra or non-matching rows from the staff table. The only difference is that I positioned staff to the right of the join operator in the first example, so I'll get the extra rows from the right table, which is staff, and in the other case, I've positioned staff to the left of the outer join operator, so I'll get the extra or non-matching rows again from the staff table, but this time it's in a different position. So in terms of the general content of what the two queries will produce, they're going to give you the same information. The only twist in terms of what's different with these particular examples is that I opted to show all of the columns in both cases. Because I requested all of the columns that will be shown first in a left to right display will come from whatever table is listed first. That is the table that precedes the join operator. So here I'll get all of the columns from department shown to the left of the columns from the staff table. But here, because I listed staff before the join operator, the staff columns will come before the department columns. That's the only twist that makes the two queries different. In terms of the number of rows and the exact data content, the two queries produce the same result. So I could get that result whether I use a left or a right outer join. It doesn't make a difference. So technically, I don't need both operations. Furthermore, if I do this in reality, very, very rarely am I ever going to say select asterisk from a single table, let alone say select asterisk from the result of a join. I'm going to enumerate the columns here and say I want the department column from the department table, the building column, the e-name column, the e-title column, and I list what they are. And provided I list them exactly the same in the left to right order, then these two queries would then become exactly identical. Okay, let's go into the database for a moment, because as exciting as this stuff is to hear about, it's probably a little bit more exciting if you actually see that it really does something. So let's go ahead here and take a look at this. Okay, I've connected as our good old student user, and let's take a look at the query here that says select, and we'll go select everything from, and we'll start with department, and we'll do an inner join with staff. The condition is the department tables DEPT column is looking for something that is exactly equal, an exact match, in the staff tables DEPT column. And again, we get the same 6 rows that I had mentioned to you. Okay. Now, notice there are 6 rows, and you look at the department column. For the department table, only 2 values. So now, let's modify the query. And what we'll do is say, let's select everything. But this time, what we'll do is we'll say left outer join. So what we're going to do is the outer join, but it's going to be such that in addition to the inner join result, we're also going to include the extra or non-matching rows from the left table, which as we've expressed it here, is the department table. So notice we went from 6 rows, we now have 8 rows. Where do the extra 2 rows come from? These rows come from the department table, the departments that didn't have any employees, right, that didn't satisfy this condition. And what you have over here are all null values. These are null extended rows. Let's give you a slightly different twist to this. Let's take the query and say select everything from, and we'll say department right outer join staff, same join condition, and this time we get a total of 9 rows. Where do the 9 rows come from? Well, we have the 6 rows that constitute the inner join result. Then we have 3 additional rows from the right table, staff. That's where we've got good old Euclid, Archimedes, and Da Vinci. And remember, there is no math, there is no engineering, there is no null value in the department table. That's why these guys don't show up. But also note that we don't see CIS and management because we requested the extra or non-matching rows from only the right table. And in a previous case, we didn't see Euclid, Archimedes, and Da Vinci because we requested the extra or non-matching rows only from the left table. So those 2 forms of the outer join allow us to identify which of the 2 tables will have its extra or non-matching rows preserved. From the other table, we're going to get only the rows that find a match or satisfy the join condition. So that hopefully gives you a pretty good idea of how the left and right outer joins behave. Let's go back here. Okay, we've given you the examples and we've shown you how they behave. Now, there is a third variety, and I'm sure you're anxious to see this one, the full outer join. Well, what is the full outer join? Where we said that the left outer join preserves non-matching rows from only the left table, and the right outer join preserves only the non-matching rows from the right table, the full outer join gives us the inner join plus the non-matching rows from both tables, the non-matching rows from the left table, and the non-matching rows from the right table. Now, all we have to do is say, select from one table, full outer join the other table. And we'll get the inner join plus extra rows from the left table plus extra rows from the right table. So pretty straightforward, I think, to see what that's doing. However, I bring to your attention a couple of important points. That the full outer join again produces the same rows as we'll see in the inner join plus extra rows from both the left and the right. But the question that I raise to you is, well, I say in practice the full outer join, it may have only limited practical value. Why is this the case? Why would the full outer join be not as useful as the left or the right outer join? Think about that for a moment. Well, when you are connecting rows, typically the rows from one table that you're relating to rows from another table have been identified to the database as being related in some way. That is, referential integrity is in effect. So for example, normally you would say, well, I've got employees, say in my staff table, And DEPT from department would be a foreign key that maps to the primary key of the department table. That's how most tables are going to be set up in practice, right? You're going to have a parent-child relationship identified in your data model and subsequently defined to your database. So you've got a foreign key. The foreign key is going to have to match the value of the primary key. Well, there's one exception to that we'll mention in a moment here. So the tables related through referential integrity, we don't say we'll never have non-matching rows, but we'll generally not have any non-matching rows. The only way that we can have non-matching rows, it depends on the delete rule. See, normally what you have is the foreign key must match exactly the value of the primary key of some row in the referenced or parent table. So for example, if you have an employee who is assigned to CIS, there must be a CIS department, hence a primary key of CIS in a department table. You've got an employee assigned to philosophy, then there must be a philosophy department. But if you have someone who's assigned to, say, math, and you don't have a math department, you have violated referential integrity. So what we're recognizing here is that staff and department do not participate in such a relationship. DEPT from staff is clearly not a foreign key to DEPT from department. Otherwise, we wouldn't have the math or the engineering employees because we don't have any such department. But go back to Da Vinci. Da Vinci's the exception. Da Vinci has a department of null. This is where the delete rule for the foreign key comes into play. Is it possible for an employee to not be assigned to any department? That would be Da Vinci's case. You say, well, I've got an employee who's assigned to philosophy. I've got an employee who's assigned to computer science and so forth. They are assigned to existing department. But is it possible, maybe at some point in time, maybe just for a short duration, but is it nonetheless possible that an employee could be working for the company but not officially assigned to any department? In such a case, the department ID for that employee, the foreign key value, would be null. So if nulls are permitted in a foreign key, then when you do your regular inner equijoin, you're going to have a null, and that's never going to be equal to anything over here. So therefore, you would not get that employee. So that would be kind of the exception to the comment that I make here. It is possible that you could find a practical use for doing a full outer join. You could have an employee who's currently not assigned to any department, in which case it's null and wouldn't match on an equal condition. The other case, of course, the flip side is you could always have a parent that would not necessarily have a child. So you would want to have at least the left outer join and designate that parent table, say the department table, as the left table to show the other departments. That's how we started our whole presentation in this video. But we're talking about this other situation, which is kind of interesting. So there is a possible way to say, yes, I could use the full outer join. But in practice, it's not going to be all that common. Consider this example here. If we look at our academic tables and talk about these administrative units of departments, and we have these courses. Courses are effectively sponsored by a department sponsors courses. A course cannot exist in our database unless it is under the sponsorship of some existing department. So that means the foreign key of C department must match the value of the primary key of DEPT in a department table for some row in that table. That identifies the department that sponsors this particular course. So we could never have null. You just can't create a course and say, well, we'll figure out who's going to be responsible for it later. You know, it might be the math department, it might be the computer science department, it might be the art department. Who knows? We'll figure that out later. That's not allowed in our particular application. So our system says there must be a department that sponsors the course. Foreign key cannot be null. Therefore, when you go and do a join, if you do an inner join, in fact, let's take this and show you how this works to drive home the point. Let's suppose I say we're going to select course number, course name, course department from the course table, and we'll also select the department and the building from the department table. And we'll say course, and we'll do an inner join first, where C department is going to be equal to DEPT. And again, because we're doing condition join, we specify that condition in the on clause. And we get 14 rows. Very quickly, as a reminder, let's look at what we have in the course table. 14 rows. So what does that tell us? It tells us that every course found a matching department. Because C department is not permitted to be null, it has to match. So now let's take the query we were just looking at and make a bit of a modification to this. Let's go back and say, let's do a left outer join. This will say, give me the inner join, the same 14 rows that we just identified, plus show me all of the rows in the course table that don't refer to an existing department. And we get exactly 14. This is exactly the result of the inner join. There were no extra or non-matching rows from course. There cannot be any. It would violate a business rule that we defined in our data model and subsequently implemented within our database. However, if we take the right outer join, this is saying, let me look at those departments that have courses, as well as any department that currently does not sponsor any courses. And all of a sudden, we get 15 rows in the output because management at the moment does not sponsor any courses. So we picked up a parent that has no children, but you'll never have a child without a parent if you have referential integrity where the delete rule says restrict or cascade. The primary key is always not null, but the foreign key is not null. So the inner join and the outer join that says, give me the children that don't have parents, will always be the same. So what does that mean? Well, what it means is you could do the full outer join, but it's kind of a waste of energy to do the extra stuff that says, give me all of the inner join plus the courses that don't match, and the system goes and looks and said, well, I'll go through and look, don't find any, but it went through that effort, and then show me the departments that don't match. Oh, and I found one. So the idea is, this is the way it exists in most practical implementations in the real world. But if you allow nulls for foreign keys, then the full outer join may be of some actual practical value to you. So that's what I want you to keep in mind there. Okay, so every course has to be sponsored by a department, which means the foreign key cannot be null. The inner join of course and department will produce every course because every child has a parent. And then a department might not sponsor any courses, so it is a possibility that you can have a parent with no children. And with that background, which I gave to you already, we demonstrated the exact behavior, and it seems to be quite reasonable. So for this situation, then, full outer join produces the same result as simply the right outer join, because we designated department, the parent, as the right table. So kind of keep that in mind. Now, one other twist. If you were thinking, well, that's not so bad, I think I got the hang of the outer join. Well, here's where maybe I throw you a curveball. The outer join, just like an inner join, can include more than just the join condition. We can include filter conditions. But remember, we're using the on clause to express the join condition. We recommend using the where clause to introduce the filter conditions. If you do that with an inner join, then it really doesn't matter where you put the filter, whether you put them on the on or the where. But when you use an outer join, you have to be sensitive to the fact that it's going to behave differently depending upon which table the filter is applied to, whether you include the filter in the on or the where clause. So just be careful with this. The outer join allows the filter either in the where or the on clause, but the semantics are going to be different because there's a difference in the timing as to when the filter is applied. So in this query here, we're saying course left outer join class. Class is over here as the right table, and we're doing a left outer join. And notice we're using the correlation variable of L. So we're saying, here's the join condition. That's straightforward. But then also an extension of the on clause, we say, let's do a filter on the right table. Right? Because class is designated as the right, and CDay is a column in class. The filter applies to the right table. So what happens? The filter is applied before the outer join is evaluated. So what that means is the classes that are held on Tuesday are the only rows from the class table that are used to apply the outer join with course, because we did the filter before doing the outer join. On the other hand, if we put that filter for the right table in the where clause, then the filter is applied after we've done the join. So what will happen is we will have done the left outer join of course in class, produce that whole result, and then filter down that result by looking at the CDay being Tuesday. So the filter condition, the timing differs as to when it is evaluated. Significant point, because it could make a difference in the result. Okay, so let's look at what happens when we go to the left table. Right, we were applying the filter to the right table. So let's look at the left table, and we're saying you could apply the filter before or after the outer join. So when you put the filter in the where clause, it is again evaluated after the outer join. So here the left table is course, and we're doing a left outer join. So here's your join condition, and then we're doing a filter on the course table in the where clause. So this is saying do the outer join and then afterwards filter out the CIS department. Whereas in the other case, if we put the filter in the on clause, we filter out the C department of CIS before doing the outer join. Very subtle difference, but it can produce different results, and I encourage you to try out both of these variations on your own to see how you understand it and see what the difference is. Okay, very interesting, very subtle. So you can get slightly different results or significantly different results depending on the timing of the evaluation there. So play around with that and experiment. Okay, that's the filter conditions, and we're pretty much at the end. So let's summarize what we've talked about. Reminder that the join operation is a multi-table operation, and what it serves to do is to combine rows from two tables. Remember, the join, strictly speaking, is a binary operation. So we take the concatenation of rows from the two tables, the two rows that we're currently considering that satisfy the join condition, we append one to the other. So the inner join then returns all the rows that satisfy the join condition. The result of an outer join, which is what we just discussed in detail in this video, includes all rows produced by an inner join plus additional rows from either one or both of the tables, depending upon which variety of outer join we applied. Remember, the left and right outer joins each produce non-matching rows from one of the tables, where it depends upon which operation we're using, left or right, and which table we've designated to the left of or to the right of the operator. Again, applying an infix operator. And then finally, we can include filter conditions in either the on clause or the where clause. And if we're doing an inner join, it doesn't make any difference. But if we're doing an outer join, it can make a difference depending upon which table is being filtered, because again, it is determining when the filter is applied, before or after the outer join is performed. So there's quite a bit of interesting stuff here that you want to consider. You can take this a step further as well. And if you're interested and send me some comments, I can put more on the outer join together, because we had indicated that the inner join says you can join one table with another, but then you could add a third table and a fourth table by doing additional joins. Well, it gets a little bit more interesting when you try to do 3 tables being joined with an outer join, 4 tables coming in with an outer join. So if you're curious about that, you can do some research on your own, or if you'd like me to put something together, acknowledge your interest in that in the comments section and let me know, and I can put something together. So again, as with the other videos, this has a file associated with it, which will include the outer join examples that I've used. So go to the website, www.timhartley.com, locate the Insightful Professor link in the menu, look on that page for the available files for download, and there will be a section labeled Outer Join where I'll post the examples that I used in this video, and you'll be able to grab that code and not have to type it in. So hopefully you found this useful and informative. If so, offer some comments. Let me know how you respond to this. If you feel positive about it, give me a thumbs up. Let me know I'm doing what you want. And once again, thanks for watching.